Section 5.2, another sections on systems of equations, but now we have three variables and three equations. All right, so first off, showing that an ordered triple is a solution. Again, exactly what we did when we had two equations with two variables. It's just making sure that that ordered triple, okay, which is an x value, then a y value, and then a z value, so alphabetical order there. Make sure when you plug that in, it actually does work for all equations. Equation 1, equation 2, and equation 3. Okay? So you plug them in. Equation 1. All right, if I plug in a negative 1 for the x, all right, a 2 for the y, and a negative 2 for the z, we're saying does that equal to 9? So negative 1, 2 times 2 is 4. Negative 3 times negative 2 is positive 6. All right, and so negative 1 plus 4 is 3, and then 3 plus 6 does in fact equal 9. So that works out. We got to make sure it works in equation 2. All right, 2 times the negative 1 minus the y value of 2 plus 2 times the proposed solution z value of negative 2 is that negative 8. Well, that gives me negative 2 minus 2, and then 2 times negative 2 is negative 4, and that does in fact give me negative 8, so it works out. All right, so we got to make sure it works in all three equations, so let's try equation 3. All right, we have a negative x, so a negative negative 1, plus 3y, or 3 times the y value of 2, minus 4 times our proposed z value of negative 2. We're saying, is that in fact 15? Positive 1 plus 6 plus 8. That does give me 15, so that works. So yes, we show that ordered triple is a solution. I would practice that, okay? On your test, since it's going to be multiple choice, you could test all your solutions and see which one works in, okay? Because doing the actual workout is going to be a long process, as we will see. All right, here's the process. First thing we'll do is reduce the system to two equations and two variables. Usually accomplished by taking two different pairs and using an addition method to eliminate the same variable from both pairs. Then we'll resolve the resulting two equations system like we did in the previous section. Back substitute twice and then check. All right, so this is how it works. I'll look at my equation and say, all right, what variable should I get rid of? All right, I'm looking at the z's because the z's have the smallest number values, okay? And so I'm going to look at equation 1 and equation 2 together. I'm going to pair those up and say, hey, how would I get rid of the z's if those were paired up? This is already negative 4, so if I could get this to be positive 4, that would work out. So if I multiplied, let me just rewrite equation 1, 5x minus 2y minus 4z is equal to 3. All right, and if I can say 2 times equation 2, that would give me 2 times 3 would give me 6x. 2 times 3 would give me 6y. And 2 times 2 would give me 4z. And 2 times a negative 3 is a negative 6. If I do elimination now, I'll get 5x plus 6x, which is 11x. I'll get negative 2y plus 6y, which is positive 4y. The z's will cancel out, and 3 minus 6 is negative 3. All right, so I'll call this equation 4. All right, so I paired up equation 1 and equation 2, and I got rid of the z. All right, now I need to get another pair. All right, and so I'm going to pair up equation 2 and equation 3. Equation 3 has got to be in there. All right, because that's the one I have not used. And let's see, I want to get rid of the same variable. I want to get rid of z. So 2 and 3 will both go into 6. So if I take equation 2 and I multiply it by 3, 3 times equation 2, 3 times the 3 would give me 9x. 3 times the 3 would give me 9y. 3 times the 2z would give me 6z. And 3 times the negative 3 would give me negative 9. All right, now I'll go to equation 3. I'm looking at the z's. I'm trying to get rid of the z's. So if I multiply that by negative 2, negative 2 times the 3 will give me the negative 6z, which is what I want. So negative 2 times equation 3, that will give me negative 2 times negative 2 is positive 4. Negative 2 times 5 is going to give me a negative 10. And then negative 2 times 3 is going to give me a negative 6. And negative 2 times 3 again will give me a negative 6. I put those together. This gives me 13x minus 1y. The z's go away. That gives me negative 15. And I'll call that equation 5. All right, so I've done a lot of work so far. What I've done is I've taken that three equations and I've broken that down into 2 equations. 11x plus 4y is equal to negative 3. And 13x minus y is equal to negative 15. Okay, that's my equation 4 and equation 5. All right, now I want to do it again. What variable should I get rid of here? I'm guessing the y probably. All right, so if I leave equation 4 alone, 11x plus 4y is equal to negative 3. And I multiply equation 5 by 4. All right, 4 times 13, excuse me, will give me 52. 4 times 3 is 12, yep. And 4 times the negative y will give me minus 4y. And 4 times negative 15 will be a negative 60. And when I do that together, 11x plus 52x gives me 63x. The y's will cancel out. Negative 3 and negative 60 give me negative 63. And if I divide the 63 over, I get x is equal to negative 1. So I've got 1/3 of my ordered triple. So I'm going to back sub. All right, so if I back substitute, I'm going to take that negative 1, I'm going to plug it back into one of these equations, either equation 4 or equation 5. All right, I'm going to do an equation 4. So equation 4, 11 times the negative 1 plus 4y is equal to negative 3. All right, so negative 11 plus 4y is equal to negative 3. All right, if I add the 11 over, this gives me 4y is equal to a positive 8. I divide the 4 and y is equal to 2. So now I've got the x and I've got the y. And so I've got to go back substitute one more time. And so I'm going to go back to one of my original equations. And I know x is negative 1 and y is 2. Okay, I'm just going to use Let's see. I'm going to use equation 3. Okay, but you got to use one of your originals. So equation 3. All right. -2 times my x value of -1 plus 5 times my y value of 2 plus 3z is equal to 3. I'm going to solve for z. All right, so if I multiply through, that gives me a little room. 2 plus 10 plus 3z is equal to 3. So 12 plus 3z. I combine like terms, subtract the 12 over, this gives me 3z is equal to -9. Divide by 3, z is equal to -3. So if I've done this correctly, I've got x of -1, y of 2, z of -3. So let me write that answer out. -1, 2, -3. All right, but again, I'm going to check my answer. If I've done all the work, I might as well go a little bit further and check my answer. So 5 times the -1 will give me -5. All right, 2 times the 2 will give me 4, so -5 minus 4. And then -4 times the -3 will give me plus 12. -5 minus 4 plus 12, that does give me 3. So equation 1 works. Equation 2, 3 times the -1 would be -3. All right, 3 times 2 would be 6. 2 times -3 would be -6. So -3 plus 6 minus 6 is going to give me -3. That works. Let me try the last one. -2 times -1 is +2. 5 times 2 is 10. 3 times -3 is 9, or -9. 2 plus 10 minus 9 does give me 3. So I'm confident that that is my answer. I know it's a lot of work. Okay, begin the steps. Pair them up to get rid of the same variable in both. That's going to leave you with 2 equations with 2 variables. Get rid of one of those variables by doing the addition method again. That gives you one of your answers. Back substitute into one of the equations with 2 variables. Get your second answer. And then take those 2 answers and back substitute it into one of the original equations to get your third. All right, so last problem here. All right, I've got 3 equations again, but notice my first equation does not have a y in it. Okay, so I'm just going to go ahead and write that one over. I'm going to bring that one over and say, hey, x plus z is equal to 8. Okay, and so if I can just pair up that second 2 equations and get rid of the y, since the first one didn't have a y in there, I've got actually less stuff to do on this one. So how can I get rid of this y? This one's 2 and this one's 1. So if I multiply the second equation by 2, so 2 times equation 2, that gives me 2x plus 2y plus 4z is equal to 34. And then I'll bring equation 3 over. Oh, I need one of them to be negative, don't I? So let's go ahead and multiply by -1. So -1 times equation 3. So -1x minus 2y minus 1z is equal to -16. 2x minus x, I got 1x. The y's go away. I'm left with plus 3z. And that's 16 there. 34 minus 16 is 18. So equals to 18. I'll call that equation 4. All right, but if I look at equation 4 and equation 1, they both have just x and z in them. So I can put those together. X plus z is equal to 8, and x plus 3z is equal to 18. All right, so now I just need to get rid of one of those variables. The x's are almost the same, except one of them needs to be negative. So if I multiply equation 1 by a negative, this gives me negative 1x minus 1z is equal to negative 8. I just bring equation 4 over, x plus 3z is equal to 18. The x's cancel out. Negative 1z plus 3z is 2z. Negative 8 plus 18 is 10. Divide by 2, I got z is equal to 5. If I plug that back into equation 1, back substitute. Okay, equation 1 here, since that just has x's and z's in it, I'm going to have x plus 5 is equal to 8. That means x has to be 3. And so if I back substitute one more time, I'm going to use equation 3. All right, I'll have 3 plus 2y plus 5 is equal to 16. That gives me 2y plus 8, when I combine like terms, is equal to 16. Subtract the 8. 2y is equal to 8. And then divide by the 2. That's subtracted the 8. 16 minus 8 was 8. And so if I divide the 2, y is equal to 4. So if I've done this correctly, I've got x is 3, y is 4, z is 5. So an ordered pair of 3, or ordered triple, excuse me, of 3, 4, 5. I check my answer. I've done all this work, might as well check it. For equation 1, 3 plus 5, that's 8. Equation 2, 3 plus 4, 2 times 5 is 10. 3 plus 4 plus 10 is 17. That works. 3, 2 times 4 is 8. And plus the 5, 3 plus 5 plus 8 is 16. That one works. I know my answer is good. Okay? Takes a lot of work. Try MyMathLab. You're going to have to do a lot of work on MyMathLab. Remember, if you can check your answers in a multiple choice situation, it'll save you some work. Good luck. Email me if you have questions.